Okay, here are some problems from section 9.2 and number 32. They want you to find the coefficient of x to the fifth in the Maclaurin series generated by sine of 3x. So I look at my table over on page 491, and I got my Taylor series sine of x, and we're looking for the fifth, x to the fifth coefficient. So we just take this out to the term involving x to the fifth. So it's x minus x cubed over 3 factorial plus x to the fifth over 5 factorial. And I want sine of 3x, so I'll put 3x in every time I see an x. And then I'm looking for this coefficient of x to the fifth, so this is what I'm looking for. 3x to the fifth over 5 factorial. And I'll just separate this 3 to the fifth times x to the fifth over 5 factorial. And I'll put the 3 to the fifth over 5 factorial. And this is the coefficient of the x to the fifth. That's all we want. And I can write it over here. 3 times 3 times 3 times 3 times 3 over 5 factorial, 5, 4, 3, 2, 1. And the 3's cancel, so I've got 3 times 3 is 9 times 3 is 27 times 3 is 81. All over 5 times 4 is 20 times 2 is 40. So that's all they really needed you to do. Okay, number 33. Alrighty, here's 33. And 33 says, what's the coefficient of x minus 2 to the third in the Taylor series generated by the natural log of x at x equals 2? So I need to find the derivative, the third derivative, because that's going to be part of the coefficient. If I look at Taylor's formula, I want the coefficient of the x minus 2 to the third. So this is going to be the term that involves the x minus 2 to the third. That's also going to be the third derivative at 2 over 3 factorial. So this is what I'm going to be looking for. The third derivative over 2, third derivative at 2 over 3 factorial. That's the coefficient of the x minus 2 to the third term there, for the coefficient of that. Okay, so I need to find my third derivative. So this is the natural log of x. That's the first derivative, 1 over x. Second derivative is negative 1 over x squared. Third derivative is 2 over x cubed. And I want to evaluate that at 2. So that's going to be 2 over 2 cubed, or 2 over 8, which is 1/4. So this is my coefficient that I'm looking for. And that's 1/4 over 3 factorial, which is 6, or 1/4 times 1/6, which is 1 over 24. So that's what you're looking for. Okay, not too difficult, I don't think. Okay, number 34. Let's see, here we go, 34. Writing to learn, review the definition of the linearization of the differential function of f at a in chapter 4. What is the connection between the linearization of f and Taylor polynomials? Well, if we look over page 233, we just call it a tangent line. We don't really use this formal definition because it is a tangent line. We put the f of a over there, and we kind of simplify it. But this is actually the formal definition, and if you think about it, it makes sense. The linearization is f prime of a, that's your tangent, and this is just the equation of the line. We just put the f of a over here. We leave it in terms of f. So it's f of a plus f prime of a times x minus a. That's the definition. If you look over again on page 233, you see L of x. That's from chapter 4. Now if we take Taylor's formula, and this is f to the k of a, all right, this is centered at a, all over k factorial x minus a to the k power. And if I look at the first piece of 1, if I look at the first order Taylor polynomial centered at a, that's just going to be f of a all over x to the 0 over 0 factorial plus f prime at a over 1 factorial times x minus a to the first power. If I just look at that first order polynomial and I simplify it, this is going to be anything to the 0 is 1. That's going to be 1, so this is just going to be f of a. And 1 factorial is 1, so this is just going to be f prime of a times x minus a. They're the same. So L of x equals the first degree Taylor expansion. Okay, so that's 34. Okay, number 36. According to the table of Maclaurin series, the power series converges at x equals plus or minus 1. So you look on your tables, and then if you look at your table, and you'll see on number 36 that x minus x cubed over 3 plus x to the fifth over 5, etc., etc. It's our general term. That's actually equal to the inverse tangent. So we want to know, okay, what number does it converge to when x equals 1? Well, I just take the inverse tangent of x. I take the inverse tangent of 1. The angle whose tangent is 1 is what? Pi over 4. That's when x is equal to 1. When x is equal to negative 1, the angle whose tangent is negative 1 is negative pi over 4. That's all. So those are pretty straightforward. And we can try number 37 while we're at it. Number 37 basically as a true or false questions, but they want you to justify your answer. And they give you this, if you look at 37, you've got this Taylor series, and that's going to be x minus x cubed over 3 plus x to the fifth over 5, etc. So that's what they're referring to. And they say true or false, f of 0 equals 0, justify your answer. Well, the constant term, remember, if you look at the constant term, that's f of 0 times x to the 0 over 0 factorial. So those are all going to be 1, and it just depends on what f of 0 is, so it just ends up being f of 0 times 1. But if you look at the expansion, you don't have a constant term. So since the constant term is equal to 0, f of 0 must be 0, because that's what the constant term is, f of 0 times 1. So the constant term is 0, therefore f of 0 must be 0. Okay. And then number 38, referring to the same series. Actually, yeah, it's just 37, 38, referring to the same series. It says true or false. This is true. I should underline that so I can find it here. There we go. It says 38, it says the f triple prime, the third derivative at 0 is negative 1/3. Let's see what that is. So if I look at my series over there, the third derivative, f triple prime, will be whatever's in front of x to the third. In other words, if you look at your Taylor's formula, it's f triple prime of 0, x to the third over 3 factorial. So whatever's in front of the x to the third is going to be this. But if you look at your series, this one was your series, you had negative x to the third over 3. So if you factor the 3 out, the 1/3 out, you have negative 1/3 times x to the third. This is what your series looks like. Okay, on page 493, this is the x to the third coefficient is negative 1/3, but by Taylor's formula, it has to be f triple prime at 0 over 3 factorial. So we set these equal to each other, we could find out exactly what that is, what the third derivative is. So I'll say negative 1/3 equals this. All right, and then I can just multiply by both sides by 3 factorial, which is 6. So that ends up being negative 1/3 times 6 equals f triple prime of 0. But that's just going to be negative 2. So the answer is false. It's not negative 1/3. It is negative 2. Okay, so the answer is false. Okay, I hope that helps.